One of the new and unheralded features introduced in the recent release of Rails 8.1 is local continuous integration, or local CI. This functionality provides a new DSL to let you specify all the steps needed to check your app, from running tests to verifying code quality to doing security scans. Everything you need to let you confidently deploy new updates of your app to production and to do it fast. Most web apps these days use third-party services like GitHub Actions, Circle CI, and GitLab's integrated CI/CD tools to run all the checks necessary before pushing out changes into the world. These services cost very little to use and may even offer free tiers to get up and running. However, these services require some initial setup time to get working right, and the free or entry-level tiers use virtualized environments that are often slow and underpowered, often creating inconsistent results and becoming one of the main bottlenecks in your ability to ship. The idea behind local CI in Rails is to eliminate that bottleneck by having your local development system serve the same purpose of checking that your updates are ready to go. The average software development system these days is decked out with high-powered multi-core CPUs, gigabytes of memory, and super fast hard drives. We can harness these resources by running the same CI flow in a fraction of the time as a cloud-based CI service. New apps created with Rails 8.1 will have the local CI functionality ready to go. But for existing Rails applications, you'll have to set up a few things on your codebase. In this video, I'll teach you how to set up an older Rails app to take advantage of this new feature. For this example, I'll use a Ruby on Rails application called Airport Gap that you may have seen many times on this channel. I created this app in 2019 using the latest version of Rails at the time, which was 6.0. Currently, it's running on Rails 8.0, so let's update it to the latest version of Rails to have the new local CI functionality available. The first step is to update Rails in the application's gem file. As of this recording, the latest version of Rails is 8.1.1, so I'll update my gem file to use that version. Running bundle install after updating the gem file gets the app already using Rails 8.1, but we also need to ensure that we have all the new configuration files and scripts provided in this new version. When upgrading a Rails app to a new dot version, for example Rails 8.0 to Rails 8.1, it's recommended to run the app update task with bin/rails and the app:update command. This task goes through your app's configuration to determine whether it needs to generate new scripts and configuration files, as well as update existing ones. Depending on your app, it takes a couple minutes to verify the diffs for existing files. If you run this task regularly anytime you update a Rails app, most changes are minor or inconsequential, like updated punctuation in a comment. For the most part, it should be safe to keep your existing configuration files intact and let the update task create any missing files that Rails 8.1 now generates by default. While this step can be a bit tedious, it's critical to pay attention and not blindly accept new changes, as it can modify your app's behavior in ways you didn't intend. Going from Rails 8.0 to 8.1 is straightforward with minimal changes on the backend. However, you may have some dependencies in your gem file that haven't been updated to work properly on Rails 8.1. If you have any errors or deprecation warnings when updating to Rails 8.1, make sure your dependencies are up to date and report any issues to the maintainers so they can fix them as soon as possible. As with any app update, you should run any automated tests you have in your repo and also run the app locally to make sure things are working well. The Airport Gap app for this example is relatively simple and most dependencies are already up to date, so this Rails update only takes a few minutes to verify. A final recommendation is to tell Rails to load the new version's default settings. The app update task creates a new initializer file under config/initializers called new framework defaults 8.1.rb, and it contains a commented out list of the new defaults that have changed in this new version of Rails. The purpose of this file is for developers to read through the changes and uncomment each one individually to make sure that the updates don't break your app. Once you confirm these changes won't affect any existing behavior, You can change Rails to use the framework defaults from Rails 8.1 by updating the config.loadDefaults setting in your config/application.rb file. After running the bin/Rails app update task, your Rails app will contain a few new files related to the new local CI feature. The first one is the bin/CI script, so let's take a look at it. This is a basic Ruby script that will load your application dependencies and also require the new continuous integration library that lets you use the DSL for defining and executing steps, which is the core of local CI. You likely won't ever have to touch this script, and you will only use it to run the steps defined in the configuration file located under config/ci.rb. This is the other new file generated by the app update task related to local CI. This default configuration shows how the local CI DSL works, starting with the ci.run method. This block defines the start of a continuous integration run, letting you execute different steps and show the result of each one. When all steps defined in this block finish, it exits with an appropriate code depending on the results. A zero exit code if all the steps pass, or a non-zero exit code if there are any failures. In addition to defining the start of the process, ci.run also sets the CI environment variable with a value of true during the block's lifetime. This value lets you conditionally modify the behavior of the app during the test run, such as disabling logging or turning on features typically disabled in the development environment, like eager loading. To define a step to execute in the continuous integration run, local CI uses the step method, which accepts a message to display and the command to execute for the CI run. The command can be a string, as shown in these examples, or multiple strings passed as individual arguments, which is helpful in certain scenarios, like if you want to run a command that needs to handle special characters in file names. In most cases, you'll define the command as a single string, as shown in this example. The example configuration has 3 steps, plus an additional commented out section that we'll discuss later. The first step is the initial setup for the application on your local system. This step will run the bin setup script provided by Rails, which installs the app dependencies and sets up the local database. It uses the skip server flag to bypass starting up the web server. The second step runs Rubocop to make sure our styling conventions are in place. I have a video on this channel that explains how to get it up and running for your Rails apps. The last step runs a security audit for import maps in our application. The Airport Gap application is an older Rails app that doesn't use import maps, so I'll remove this step. Let's add a new step to cover running unit tests. The Airport Gap application uses rspec for its test suite and runs using the bin/Rails spec command. I'll create a new step after the Rubocop step. The first argument is the description, so I'll call it unit tests rspec, and the second argument is the command to run, which is bin/Rails spec. With these updates, we should have a decent first pass at running our continuous integration process in our local development system for the first time. Let's take it for a spin to see it in action. In my terminal, I'll execute the bin/CI script. It goes through each step in the config/ci.rb configuration file, and for each one, it displays if the command exited successfully, along with the time it took to execute. In our first pass, we see the initial setup step succeed, as well as the unit tests passing without any issues. But the Rubocop step did fail, thus failing the local CI run. Seeing the output, I can tell it's due to the newly generated files from the app update task not following the styling rules that I set up for this project. Having the step fail here is actually a good thing, because I likely would have forgotten to check Rubocop before pushing these changes to the repository. After fixing the Rubocop offenses, I can rerun local CI by executing the bin/CI script once again. This time, I see everything was successful. This example demonstrates how simple it is to get local CI working for your Rails app, as well as the benefits of running these tests locally. I was able to detect a Rubocop issue and fix it in a fraction of the time it would have taken me when relying on a cloud-based CI service, because I had to push the code and then wait for everything to get set up and run before actually getting the results back. This CI run took less than 10 seconds in my development system, but the same steps often took over 2 minutes when running on GitHub Actions. It might not seem like a huge difference, but the time saved across your development workflow can be massive over time. Now that you've seen how to use local CI for Rails, let's take a look at the commented out section of the config/ci.rb configuration file. This optional configuration is made to set the pass or fail status of a GitHub commit after a CI run. Most teams use the status of the last commit in a branch to indicate whether it's ready to merge or not, and you can configure your GitHub repository to block merging any pull requests with a failed status. Using CI services like GitHub Actions set this status automatically for you when you open a pull request. However, given that local CI runs on a developer's machine, you'll need a way to send the status after running your tests locally. The team at Basecamp created a GitHub CLI extension called gh-handoff that does exactly this. This extension makes an API request to GitHub to create a successful commit status for the latest commit in the user's current branch. To install the extension, you'll need to have the GitHub CLI installed and set up on your local system. I won't go through the install since I already have it set up on this system. With the CLI tool working, installing the extension only requires a single command, which is gh extension install with the name of the extension, which is basecamp/gh signoff. Now that I have the extension installed, let's see how the process works. I'll uncomment this section and go through each part. After running your tests, we'll call a success method that comes from local CI to see if all steps passed. If they did, a new step will run the gh signoff command for the existing branch and send the new status for the latest commit, indicating that a developer ran CI locally and that it passed. If any of the steps failed, we'll go to the failure message to let the developer know that this branch isn't ready for merging yet. I've created a new pull request with a few changes to use as an example to test out the sign-off process. Currently, there are no GitHub Actions workflows running for this repo, so we don't know what the status of the app is at this time. I'll go back to my terminal and run CI locally using the bin/ci command, which will run all my checks along with the new sign-off process. As we can see here, all my steps passed, so the step to run the gh signoff command is triggered, and this should have sent the status of the last commit made to that branch. When I check the pull request on GitHub again, I should now see that I signed off on this branch, so now everybody knows that it's ready to merge. Hopefully after watching this video, it's evident that the local CI functionality can help speed up the feedback cycle for validating that a Rails app is working as intended. However, in the short time I've used it, it's not well suited for all scenarios. One example is if you need to make sure your app runs on a different architecture than your local system. For instance, you might do your coding on a new Mac system which uses the ARM architecture, but you deploy to a Linux server which uses the x64 architecture. Many third-party CI services offer multi-architecture builds, which is difficult to replicate locally. Another reason to continue using cloud-based CI services is if you have complex build processes. The examples used in this video use some very basic checks, which work great using local CI. However, if you have more involved testing requirements, like end-to-end testing that require having additional services set up, it might be easier to use something like GitHub Actions for it. Finally, depending on your team's workflow, your CI builds might need to generate artifacts like screenshots, videos, or logs for observability and traceability. Third-party CI services have systems in place to store and share artifacts, but using local CI keeps them in your system, requiring additional steps if you need to track and share these. While local CI isn't a one-size-fits-all solution to validating your systems, It works great on the typical Rails app development workflow. Give it a shot on your next feature branch and see if the faster feedback loop changes how you work. Chances are you'll find yourself running bin/CI more often than you'd expect. If you found this video useful and want to continue improving your software development processes, make sure to subscribe to this channel to watch more videos that help teams ship their code confidently, from development to testing to deployment. You can also check out the Dev Tester website for a written version of this video, along with more in-depth articles covering Rails, testing, DevOps, and other software engineering topics. Thanks for watching, and I'll see you in the next video.